um, checking of the system in failure. Maintainability can be broadly classified into two categories: scheduled or periodic maintenance for checking the system, and corrective maintenance to unexpected failure. A more reliable system means a system with less corrective maintainability requirements, and vice versa. Okay, the other parameter is security. The field is changed. Confidentiality, integrity, and availability are the three major measures of information security, and confidentiality deals with protection of data and application from unauthorized disclosure. Integrity deals with the protection of data and application from unauthorized modification, and availability deals with protection of data and application from unauthorized users. It means that we must deal with this protection of data and application for the system from unauthorized modification from user or non-user. It means the security. And a complementary meaning is safety. Safety is really a general meaning. Safety deals with the possible damages that can happen, for example, to the operator, public, environment, due to the breakdown of an embedded system. The breakdown of an embedded system may occur due to a hardware, for example, failure, or firmware failure. Safety analysis is a must in product engineering to evaluate the anticipated damages and determine the best course of action to bring down the consequences of damage to an acceptable level. Okay, we have other parameters, and as I told you, these parameters are non-operational quality attributes. The quality attributes for non-operational quality attributes that need to be addressed for the product, not on the basis of operational aspects, are grouped as follows: testability and debugability. Okay, what about the testability? Testability deals with how easily one can test the design, application, and by which means it can be done. For an embedded system, testability is applicable to both the embedded hardware and firmware. Embedded hardware testing ensures that the peripherals and total hardware functions in the desired manner, whereas firmware testing ensures that the firmware is functioning in the expected way. Then testing for hardware and firmware. For an embedded, and about debuggability. Debuggability is a means of debugging the product from unexpected behavior in the system. Debuggability is two-level process, hardware level, software level. Review for finding the issues created by a hardware problem. Debugging is really finding the problem in the system. And in software level, it is employed for finding the errors created by the flaws in the software. Other parameter, the other non-operational really parameter is portability. It is the measure of system independence really. An embedded product is said to be portable or portable if the product is capable of functioning in various environments, target processor, and embedded operating system. Porting represents the migration of embedded firmware written for one target processor to a different target processor. Then we have porting for firmware and for hardware. And the last one, time to prototype and market. It is the time elapsed between the conceptualization of a product and the time at which the product is ready for selling. The commercial embedded product market is highly competitive, and time to market the product and time to market of the product is critical factor in the success of commercial embedded product. There may be multiple players in embedded industry who develop products of the same category, like mobile phone. Then these parameters are main quality attributes of embedded systems. After this, we go to the main elements of embedded system. As you can see, we can see the main parts of embedded system. Memory for firmware or embedded firmware of the system. Input ports like sensors for getting the input signals. Output ports or actuators for showing us the output, really the response of the embedded system. Other supporting integrated circuits and subsystems. Communication interfaces that are very important to getting information or to sending information to other systems or embedded systems to the network or some other databases. And the main of them is system core. System core process the whole of the system. Then we need to some kinds of processors. We have different system core for embedded systems, microprocessors, microcontrollers,